The next problem says the switch is changed from position 1 to 2 at t equals to 0. Steady conditions reached before switching. Find I di by dt and d square I by dt square at t equals to 0 plus. Now it says that the steady state conditions are reached before switching. So the given diagram is 10 volts, 1 ohm, 1 Henry, 2 ohms. This is position 1. Position 2. The switch is changed from position 1 to position 2 at t is equal to 0. But the steady states are conditions are achieved. So we'll draw the circuit at t equals to 0 minus. The circuit will have 10 volt. It will be at position 1. 1 ohm resistor. Inductor will act as the short circuit. Will find the current flowing through this, and I of t is given here. So now we can find I of t, which is current at time 0 minus, which will be 10 amperes. Now we know that at time t equals to 0 plus, the current will not change instantaneously. So I of 0 plus will again be 10 ampere. That means the circuit at 0 plus, the switch will come to position 2, 1 ohm, and here you'll have the current source instead of inductor. So this will be 10 ampere, this will be 2 ohms. Now for t greater than 0, draw the circuit. You will have current source in parallel with the inductor. Since initially we have got the value of current, steady state having reached 2 ohms, 1 ohm, this is 10 ampere. Now applying KVL, I of t is flowing into this. This is again I of t at 0 plus time. So applying KVL will give me minus 2 I of t minus I of t minus 1 into dy dt. Current flowing through this will be I of t minus 10 ampere, and differentiation of current 10 ampere with respect to t will be 0. Since this is constant, so we'll have I of t equals to 0. Actually it will be dy dt of I of t minus 10. So derivative of constant is 0, so we are writing it as di by dt. So from this you will have minus 3 I of t is equal to di by dt. So I have got I of t at 0 plus as 10 ampere. So after substituting, I can get at 0 plus will be minus 3 into 10. So this will be minus 30 amperes per second. So I have got di by dt at 0 plus. I have got I at 0 plus. Now the last part is to find d square I by dt square. So for that, I'll call this as equation number, this as equation 1. So I differentiate equation 1 with respect to t. So it will give me minus 3 t square I of t by dt square. So I'll get d square I by dt square at 0 plus as minus 3 into minus 30. So I'll get d square I at 0 plus as 90 ampere per second square. This is how I got I di by dt d square I by dt square when the steady state conditions are reached.